Hello, my name is Nicolas Gomez. In this presentation, I'm going to talk about mobile network generations. When we look at the evolution of a mobile communication network, the mobile wireless generation generally indicates that there has been a change in the nature of the system, speed, technology, and frequency. The main technological development that distinguished the first generation was the use of multiple cell sites and the ability to transfer calls from one site to the next as the user traveled between cells during a conversation. On 2G, this 2G phone system differed from the previous generation in their use of digital transmission instead of analog transmission, and also by the introduction of advanced and fast phone-to-network signaling. The main technological difference that distinguishes 3G technology from 2G technology is the use of packet switching rather than circuit switching from data transmission. Consequently, the industry began to looking data optimized for generation technologies with the promise of speed improvements up to tenfold over existing 3G technologies. It is basically the extension on 3G technologies with more bandwidth and services offers in 3G. Here we can see a quick review over all four generations and his characteristics. In this one we can see a quick comparison between some date some dates, standards, services, technology, speed, multiplexing, frequency, and bandwidth. Also, the modulation on the first G was analog FM, on the second G was P quarters, DQPSK based on TDMA, BPSK, QPSK, this was on CDMA, and GSMK, this was on GSM. On the third generation, the modulation was BPSK, QPSK, 16QAM, and 64QAM. And the fourth generation, the modulation was OFDM and SCFDMA. In this diagram, we can see, apart from the transport technology migration from TDM to all IP on LTE 4G architecture, it retains main similarity to 4G AMPS network. The major difference is that the central core in AMPS was handling both user and control planes, but in 4G they are separated to allow independent growth and modernization along with extensive reduction in latency. We have to say that latency was not all factor during 1st G or initial and 2G periods. Since LTE is more of a data network and supports voice in the form of VoIP IP, it provides the flexibility in using the voice codecs depending upon various factors, but 2G networks are still having a fixed rate codec due to their radio access technology. Also, in these two diagrams, we can see how was the architecture for the first generation and second generation. As we can notice, the first generation architecture was also present on the second generation, but in the second generation, with GPRS, it was added another arm and connection to the core. This arm was the serving GPRS support node. This one was connected to the IP core, and as we can see, it connected to Internet in the final point. For the LTE network architecture, the system and structure of the scheme changed a lot because here the central core was on the packet data network gateway. This connected to internet, and so in the other arm we can see how the home subscriber server was the other endpoint. At last but not least, 5th generation networks. The physical layer and data links define 5G wireless technology, indicating that this is an open wireless architecture technology. To do this, the network layer is subdivided into two layers: upper network layer for the mobile terminal and a lower network level for the interface. Here, our routing is based on IP addresses that will be different on every IP network around the world. In 5G technology, the loss of a bitrate is overcome by the Open Transport Protocol. The OTP is supported by transport and session layer. The application layer is for the quality of the service management through various types of networks. 5G advances a true wireless World Wide Web world. This generation is not comparison to the other ones because it's supposed that this generation will arrive to the public by 2020.